Hello students, this is Rashmi Deshpande, Assistant Professor, Instrumentation Engineering at DYPCO Yakulti. A warm welcome from our side to the second semester of third year instrumentation. There are 5 various subjects in this semester, one of which is Instruments and System Design. This course will be conducted by myself. So this is a very introductory lecture or introductory session for ISD. ISD is Instruments and System Design. And before going directly to the contents of syllabus of ISD, let us first try to understand what this subject has to offer to us. What is its significance for instrumentation engineers? So, let's consider engineering outcomes. So, when we take admission for engineering, what all are the expected outcomes from students' point of view? So the first major outcome is placements. Yes, we do engineering to grab a good job opportunity. Second, higher studies. Most of the students today, they won't stop their education, they won't stop their academics only after B. They would also like to go for higher studies, India or abroad. And the third important thing is most of the students, they also have an interest to be entrepreneurs in their life. So what is an entrepreneur? Entrepreneur means they would like to own a business or they would like to own a company. So now when we are talking about all these 3 engineering outcomes, most of the times we try to work on certain product. During our engineering days, we work on certain projects. And when we complete our engineering, or of course during engineering also, when we want to bring our successful project into market as a product, what all knowledge we will need, all those things they come under ISD. So let's look at ISD from that point of view. So now I would request you to pause this video for a minute and think what all knowledge or what all things you as students will need if you want to convert your successful project into a product. So I request you to pause the video for a minute now. Yes, so now I think that you are done with your work and you have jotted down certain points which you will require if you want to convert your project into a product. So maybe your probable answers might be: the first and the most important thing whose knowledge is required if you want to bring something sellable into the market is the standards given by that particular country. See, we all are looking for a global market. So I just cannot prepare anything here in Pune and I cannot just go to some European market and start selling it. There are standards which are laid down by each and every government, and your product needs to adhere to those standards. So there are local standards, there are national standards, there are international standards also. So we as engineers, when we are trying to bring a sellable product into market, we should have a thorough knowledge of international standards. This is one thing. Second thing, noise reduction. So most of the times we have seen that some amount of errors or some amount of noise are still allowed in our college projects. But when we are trying to sell that project as a product in the market, there are so many restrictions on noise, isn't it? So when we are buying a CRO, and what if the CRO is flickering every now and then? Naturally, we won't like to buy it. Similarly, there will be people who are trying to invest their money into your product and they are expecting your product to be entirely noise free, to be entirely error free. So what all are the techniques which we can implement with our project or product so that there is considerably reduction in the noise? So we need to look at all those noise reduction techniques. Next, this is also very important, optimization of circuit. Now what is meant by optimization of circuit? See, if you have a circuit probably on your breadboard and it is working very fine, but then if you want to sell that as a product in the market, you need to make certain changes to the circuit, like what is the size of the circuit. We also need to look at the ergonomics and aesthetics. We also need to see whether some other good methods of implementing the same thing are already available in the market or not, isn't it? So optimization of circuit means what? This is a point wherein we will always try to use the latest developments which are happening everywhere around us, and we would like to take those developments and implement them in our product. Prototypes, yes. So till now we have worked on the circuits, we have built the circuits on breadboard, but we cannot we cannot take that breadboard and go to the market and try to sell that breadboard. So we will have to prepare some sort of prototype, we will have to test it, and then only we can go for the mass production. So how these prototypes are to be created? Reliability is very important. So what if I have a circuit which works perfectly when I'm trying to work with it in my laboratory? What if I carry the same circuit to somebody else's laboratory and it doesn't work there? Or what happens when there is there is a rainy season, there is a moisture and there is a dust all around? Will your circuit work, yes or no? If something fails in the circuit, will the entire thing stop working, or there is something else that you have provided? So that also we need to check. So I think from my point of view, these are the 5 important points that each and every one of us should know thoroughly if you want to bring your project into market as a product, isn't it? So all these things are embedded in this these are the 5 important parts of ISD. Now before we go into details of ISD, let us see how the subject we are going to conduct this subject. So look at this, 306271 is the code for subject instrument and system design. We have got 4 theory lectures, 2 hours of practical for each batch. There is 30 marks of in-same paper, 70 marks of end-same paper. There is no practical exam, there is no term work, but yes, we do have an external oral of 50 marks. So totally for ISD you need to score against 150 marks, isn't it? The credits are 5. For theory we have 4 credits. For this your external viva we have a credit of 1. So this is the examination scheme, the credit scheme, teaching scheme for this subject called as ISD. Now prerequisites for ISD. Now when we are going to study ISD, what all are the prerequisites? Now as I already told you, here what we are going to do, we already have a perfectly working project with us. We are trying to make some small changes in this project so that we can convert it into product. So which means that by this time, before we are trying to study ISD, we are already aware of these 2 subjects, Basic Electronics Engineering and LIC. So here under ISD, we are not going to look into something wherein we will be actually building the circuits on breadboard. It is assumed that you are very well aware of how to build circuits on breadboard. You are also well aware of bringing the required output on the breadboard. So these 2 are the prerequisites. Until and unless you don't have knowledge of these 2 courses, we actually cannot move forward with ISD. These are the course objectives as are set by myself. So at the end of this course ISD, students will be able to, number 1, define a standard. So what is a standard? And state various NEMA and IP standards. These standards are given in detail in ISD. Students should be able to select a noise reduction technique for the given electronic circuit. Students should be able to design an analog circuit for given problem statement with the help of suitable IC. Yes, so selection of ICs, selection of solutions out of so many ICs available in the market is also it's also an important task under ISD. Similarly, not only for analog circuits, we should also be able to design a digital circuit for given problem statement with the help of suitable IC. Students should be able to list and explain various steps in PCB design. By PCB we mean printed circuit board, which acts as a prototype for electronic circuits. Students should be able to list various techniques to improve reliability of the equipment. Students should also be able to design a printed circuit board for given application. So by designing a printed circuit board means we will have to go through all the major steps like finalizing the circuit, its layout, its artwork, drilling, etching, soldering, everything, isn't it? So these are the course objectives for ISD. Now we will go unit wise. So now unit number 1, the title of this unit is Basic Concepts of Instrument Design. So what all are the major parts here? We have functional requirements and instrument specifications. As we have already discussed, we will see the basics of standards used, NEMA and IP standards with special reference to packaging standards, operational environment. Means what? If I want to use a particular product in hazardous area, what should be the type of packaging? What are the standards which are which give in detail information about the packaging standards. If I want to use the same product somewhere under the sea in some submarine, then what should be the packaging standards? So here we are going to see not only the importance of standards, definition of standards, but we will also be looking into for what kind of environment which standard we are going to refer to, and then prototyping and testing. But what I feel is, before going into details of all these things, it is very necessary to understand the product life cycle. So this point is missing in the syllabus that has been given by the university. So here what I have planned is, I have planned an additional topic called as product life cycle. So maybe we will begin unit number 1 with product life cycle, wherein we will discuss what all are the important stages through which each and every product needs to go through. And then we will go through the details of unit number 1. Now regarding references for unit number 1, these are the standards. Notes will of course be given, but still NEMA and IP standards are standards. So most of the material is available on the internet itself. Next is unit number 2. So what is the title of unit number 2? Guidelines for enclosure, components and accessories. So remember, we were talking something about noise reduction techniques. So if you want that the noise in your circuit, the noise produced by your circuit, and the noise which is present surrounding your circuit should not affect your circuit, then what all measures we need to take, all those measures come under unit number 2. So what is there? Grounding and shielding techniques are there. Noise, what are different types of noises in electronic circuits? EMI is electromagnetic interference, EMC is electromagnetic compatibility. So how we can reduce the effect of electromagnetic radiations. So those all things are there in this point. There is something called as ESD, electrostatic discharge, and how are we going to protect our product from ESD. Control panel layout, ergonomics and aesthetics. So we all know what is meant by ergonomics. Aesthetics means the look and feel. Nowadays the product should be aesthetically good, means look wise, feel wise, also it should be good, it should be beautiful. So what all things? So these are the things that we need to implement when we are trying to convert our project into product. Okay, so we will try to reduce noise, we will try to reduce the amount of disturbance that our circuit will face because of surrounding noise. We will also take care that our circuit will not produce noise and it should not disturb other equipments which are present in the close vicinity of the product, isn't it? So all these things we will be taking care of. Now references here is Noise Reduction Techniques by Oat. This is a book, and there is another book called as Electrostatic Discharge and Electronic Equipment by Warren. There are 2 NPTEL courses. The first course talks about applied ergonomics and the second course talks about the prototype. So how we are going to design the prototype. So you can, if you want, you can register to these courses also. Most of the videos, they are very useful. Questions, many questions are asked in the university question papers on these points as well. So this is all about unit number 2. Going forward with unit number 3. So unit number 3 and unit number 4 are extremely interesting units here. So what is there in unit number 3? Analog system design guidelines and applications. So somewhere at some point in time we discussed that optimizing your circuit is very important if you want to make a product out of it. So what is meant by optimizing? Look at the contents of unit number 3. So unit number 3 has got